Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Two weeks ago, we celebrated the show's third birthday and a major listenership milestone. And last week, we kicked off the second volume of our listener favorite AI platform series, sharing more stories of teams working to scale and industrialize data science and machine learning at their companies. We've been teasing that there's more to come, and today I am super excited to announce the launch of our inaugural conference, TWiMLCon AI Platforms. TWiMLCon AI Platforms will focus on the platforms, tools, technologies, and practices necessary to scale the delivery of machine learning and AI in the enterprise. Now, you know TWiML for bringing you dynamic, practical conversations via the podcast, and we're creating our TWiMLCon events to build on that tradition. The event will feature 2 full days of community-oriented discussions, live podcast interviews, and practical presentations by great presenters sharing concrete examples from their own experiences. By creating a space where data science, machine learning, platform engineering, and MLOps practitioners and leaders can share, learn, and connect, the event aspires to help seed the development of an informed and sustainable community of technologists that is well-equipped to meet the current and future needs of their organizations. Some of the topics that we plan to cover include overcoming the barriers to getting machine learning and deep learning models into production, how to apply MLOps and DevOps to your machine learning workflow, experiences and lessons learned in delivering platform and infrastructure support for data management, experiment management, and model deployment, the latest approaches, platforms, and tools for accelerating and scaling the delivery of ML and DL in the enterprise, platform deployment stories from leading companies like Google, Facebook, Airbnb, as well as traditional enterprises like Comcast and Shell, and organizational and cultural best practices for success. The 2-day event will be held on October 1st and 2nd in San Francisco, and I would really love to meet you there. Early bird registration is open today at TWiMLCon.com, and we're offering the first 10 listeners who register the amazing opportunity to get their ticket for 75% off using the discount code TWiMLFirst. Again, the conference site is TWiMLCon.com, and the code is TWiMLFirst. I am really grateful to our friends over at SIGOPT who stepped up to support this project in a big way. In addition to supporting our AI Platforms podcast series and next ebook, they've made a huge commitment to this community by signing on as the first founding sponsor for the event. SIGOPT software is used by enterprise teams to standardize and scale machine learning experimentation and optimization across any combination of modeling frameworks, libraries, computing infrastructure, and environment. Teams like 2 Sigma, who we'll hear from later in this podcast series, rely on SIGOPT software to realize better modeling results much faster than previously possible. Of course, to fully grasp its potential, it's best to try it yourself. And this is why SIGOPT is offering you an exclusive opportunity to try their product on some of your toughest modeling problems for free. To learn about and take advantage of this offer, visit twimlai.com/SIGOPT. And now, on to the show. All right, everyone, I am on the line with Zhaung. Is a senior staff engineer at Twitter and tech lead for the machine learning core environment on the Cortex team. Welcome to This Week in Machine Learning and AI.
Thank you. My pleasure to be here.
It's great to chat with you, and I'm really looking forward to digging into what you are working on the platform side of things. Before we do that, I'd love to start out with a little bit of your background and how you started working in machine learning platforms and infrastructure.
Sure. Actually, I would say there are 2 parts to this question. There's how I started working on machine learning, and also how I started working on platform and infra. So I can dive into both. Does that sound good?
Absolutely. Yeah, let's do it.
Okay. So I think ever since I was a kid, I always had an affinity to both math and computer science. So that's why I got attracted to discipline like machine learning, where I get to practice both. So I would say the first time I touched machine learning was actually in college. I was on my college's robotics team, and we programmed these robot dogs to play soccer. Those are Sony AIBOs, and the competition was called RoboCup. And we participate in this competition and program robot dogs to play soccer against each other. Um, Unlike what you would have guessed today, machine learning actually wasn't used very much in our vision system. It was actually used for a different case. We used machine learning to tune the gaits of the robots. By gait, I mean the walking posture. There's a set of parameters that needs to be optimized, and the search space is pretty large. So what we did was we essentially made the robot dogs walk back and forth on the playing field and recorded the running speed. And then we tune each parameter by a little bit and then make them walk the playing field again. Then we can compute the gradient of the walking speed with respect to that parameter we notched by a little bit. And we do that to all the parameters. And then we perform one round of gradient descent. That allowed us to optimize the running speed of our robot dogs. It's a very tedious process, actually.
That sounds super tedious.
Yeah,
And
exactly.
I remember these Sony AIBO dogs from many years ago. I didn't realize they were quite that programmable.
They were programmable, but yeah, the experience was pretty. It was not as good as today. Like, essentially, for example, if we get a segmentation fault, the whole robot turns off. Basically, the operating system shuts down. But one thing that was pretty amazing was our college's robotics team. We started as the last place in the US Open competition in around 2015.
Okay.
And the same team actually won like world championship in 2007. We
Wow.
actually beat very reputable teams like Carnegie Mellon 8-1 in terms of score. So I would say like it was the definitely hard working team, and the techniques we were using, like using machine learning to tune the gait of the robots, they worked out well.
Wow. And where did you go to school?
I actually went to Carnegie Mellon right after. I think for basically beating their robotics team definitely helped me get that offer from both Carnegie Mellon's Robotics Institute and Computer Science Department. So what I ended up choosing though was I was both a math major and a CS major in college. I ended up choosing a very mathematical field of computer science at Carnegie Mellon, where I model system performance by building mathematical models, essentially building Markov models and analyze queuing, etc., to basically predict the performance of computer systems. That's what I do in grad school.
Oh.
And I got into platform around, I would say system engineering around roughly 2 years into my PhD program at Carnegie Mellon. I interned at Google. So I worked on the basically performance modeling for the next generation storage system at Google. And I offered to, for example, build math models to predict performance there. And they were less excited. They were more, yeah, they were like, we don't want you to build math models. We want you to actually measure and tune the parameters. So this is, again, very similar to the robotics case, right? It's essentially, we have like a black box storage system, but we have many knobs we can tune. Essentially, we're looking for the best set of parameters that can actually perform best. So that was my Google internship. And afterwards, I started realizing that my PhD program, I do a lot of math, but I don't do a lot of hands-on engineering. And I actually found myself to like building stuff. And that's when I dropped out of my PhD program and came to Twitter. My first projects were actually on Twitter search, and this is where I learned to be an actual engineer and learned about system and platform engineering. And I like around 2014 or so, I led a group of people and built this trillion document scale search engine at Twitter. This allowed Twitter to index every single tweet ever published. Now you can search for Jack's first tweet setting up my Twitter, and that tweet would show up.
Oh, wow.
That's briefly how I got into platform engineering. And afterwards, I came to Cortex building machine learning platform for Twitter.
And so Cortex, is Cortex a team that grew organically in Twitter, or there was an acquisition that was part of that as well, right?
Yes, actually, there were multiple acquisitions. There was a tweet from Jack around. Jack was is our CEO. He tweeted about this around 2016, and Twitter acquired three companies. One of them is called Madbits. One of them is called Magic Pony, and one of them is called WetLab. These three companies, the acquisition formed the original Cortex org. And the original focus was deep learning research. Essentially, we inherited the DNA from these three acquisitions.
Got it. Got it. And so, to what degree was machine learning really heavily used at Twitter, or maybe the right way to ask this is broadly used? It sounds like there were some activity around search, and I imagine there were some other kind of point use cases, but was it in broad use at Twitter before Cortex?
So machine learning before Cortex was used, but it wasn't practiced in a consistent way. It was definitely used for us to do advertisements. For example, CTR prediction to fight spam and adversarial users, bad accounts on our platform, and also used to rank search. Cortex essentially in the past 2 years or so transitioned from a deep learning research org to a machine learning platform org. And Cortex is basically bringing consistency to how machine learning is used across all sorts of product teams at Twitter. So I wouldn't say machine learning wasn't used at Twitter widely before Cortex. Machine learning was widely used. But exactly because it was widely used and it was practiced, there are practitioners across many different teams. It was a very fragmented landscape, and different teams did things differently. So Cortex around 2017, our CTO Parag took over the org and started focusing the org around serving customers and being a platform team. And later, our current director Sandeep took over and continued to sharpen our customer focus. Now we are a platform team building machine learning platforms to serve various product teams. And as we currently stand, most Twitter product teams are using Cortex machine learning platforms to practice ML at Twitter now.
Is the goal of Cortex and building platforms, would you say it's to drive more consistency and efficiencies in the way folks use machine learning, or is it to broaden the kind of the base of people that can use machine learning? Not that those are strictly a dichotomy, but I'm wondering if one or the other really drove the establishment of the organization.
I think it's both. Actually, ultimately, our goal is to empower practitioners at Twitter to use ML both more efficiently and empower more people to be able to leverage machine learning. So I would say the emphasis is more on the latter. Bringing consistency itself is a intermediate goal in my mind. We're hoping to bring efficiency to the company by bringing consistency. And once everybody is practicing ML in a consistent way using our offerings, it makes our job easier to bring productivity to them. I don't know if this answer makes sense. I can further elaborate.
No, it absolutely does. And I've got one more question on kind of these meta organizational questions before we dig into some more detail about the platform there. And that is around this transition from a deep learning research focused organization to a platform organization. It strikes me that those are very different missions, perhaps calling for very different skill sets. What was the experience of going through that transition like?
Yeah, it was definitely a difficult transition, I would say, and most the biggest shift is the mindset from doing cutting edge research to serving internal customers. And the customer focused mindset is the biggest change in the org, and it took us took us a lot of effort to get our for example, engineers and researchers to be aligned on that. Part of it comes from
Did most people buy into the idea of doing that shift, or did the org turn over quite a bit in order to get there?
both. We had some turnovers as the transition, but most people actually stayed and bought into this new vision or focus. And we're now very customer oriented, and we do what our customer asks for. And we still have a research org, but even that research org is focused on, for example, improving the production model performance of our customer teams. So for people who wants to do like machine learning, deep learning research, we still have a place, but we definitely repurposed the goal of the research.
Yeah, the idea of kind of a customer centric view in providing platforms, I think, is one that makes a lot of sense. It's a very kind of straightforward approach. And I'm thinking specifically about this conversation that I recently had and was published on the podcast just a couple of shows ago with Eric Colson at Stitch Fix. And when he talked about the role of the platforms team in his group, it was the way that they figured out the features that the platform needed. It was really focused on things that their customers weren't asking for. It's like, how could they add value that the user doesn't even know about? Versus the way I think of traditional kind of product management, you're understanding requirements and kind of organizing those requirements and figuring out how to get there with a platform. Does either one of those approaches resonate with the way things tend to happen at Cortex?
I think actually both. So we can talk about our strategy for last year and this year. Last year is about adoption and consistency. We need to get our users to use our platform. And this year we started to look into, for example, ease of use and iteration speed. This is when we think about what kind of features make our users' lives easier. So I would say for 2018, getting customers to adopt our product and essentially switching from their current machine learning toolkits to our platform, a customer-focused mindset, customer-driven feature development is more valuable. We really need to listen to our customers to understand what makes them to change from their current ML toolkits and ML, for example, frameworks, switch to our offering. And afterwards, when we think about what features makes their life easier, we need to adopt strategic thinking and think about what our customers are not asking for. Does this answer make sense? So I think it's a gradual shift. In the beginning of creating this platform, we definitely need to put more focus on serving customers and catering to their asks. And as the platform matures, we'll gradually increase the strategic bets in our portfolio and do more work that's not necessarily being asked by customers, but we're anticipating.
So we've talked very abstractly about the platform. Maybe walk us through the platform now. What are the major components? How do you think about it architecturally, or how would you describe it to someone?
Sure. So Cortex right now, we offer multiple solutions in our ML platform. We offer the core model training and evaluation part, which is based on TensorFlow, and we offer data pre-processing and featureization, something we call feature store. It allows users to consistently prepare features for machine learning models, both at training time and prediction time, which is offline in offline and online context. And we offer production model serving based on JVMs. This is like a TensorFlow serving equivalent, except it's specialized and custom built for Twitter. And we have pipeline orchestration, which is a automated which is an automation solution that allows people to run dependency graphs of machine learning workloads and basically chain a dependency of tasks into a single graph and run them in an automated manner. And we have also added more efforts in our platform, including embeddings, nearest neighbor search for candidate generation. We have added machine learning observability, which allows us to observe feature distributions and also analyze models. And in the end, we also started a new team inside Cortex, which is called Meta, which is studying the bias and accountability, fairness, those concerns inside algorithmic decisions. That's a high-level overview of what Cortex comprises of today.
Lots of interesting stuff to dive into. So the first of the things that you mentioned was at the framework level.
Yes, the first one is what I mentioned is called the Deepbird. It's our model training and evaluation solution.
So maybe let's start there. What is the goal of Deepbird, and how do users use it?
Yes, so Deepbird started as so historically, Twitter Cortex uses Torch, which Lua Torch, not PyTorch. It's the initial. I would say it's one of the older established deep learning frameworks. What we noticed around 2017 was that the Torch community started to lose steam, and the TensorFlow and PyTorch started gaining popularity in the community. And Deepbird, actually, Deepbird version 2 is our effort in partnership with Google to bring TensorFlow to Twitter. So the goal of this component, Deepbird v2, is to unlock latest technology backed by Google, mostly TensorFlow and its ecosystem, and TensorFlow extended for use at Twitter. And specifically, to be more specific, Twitter is more of a Java shop. Like most of our code are either in Java or Scala, basically JVM languages, whereas TensorFlow is mostly Python and C++. So we had to build quite a lot of production gluing logic to actually make TensorFlow work at Twitter. And also Deepbird provides an additional abstraction layer between TensorFlow and our machine learning practitioners at Twitter. We do this for multiple goals. One is to reduce the complexity of using TensorFlow, because TensorFlow was actually production release was in February 2018. It's a relatively new thing, and we would like to hide complexity whenever possible. And inside the abstraction layer, we prescribe default values for different knobs, and we also include optimizations that are specialized and customized for the Twitter data centers and Twitter workload.
a ton in there to dig into. You mentioned needing to build a lot of glue code to bring this Python oriented system into your primarily JVM based
Mhm.
environment. Can you give some examples of specific things that you had to do?
Yeah, the main example I can give is TensorFlow is serving, right? So TensorFlow serving is actually a C++ app speaking gRPC. At Twitter, gRPC is not our standard RPC protocol, and also C++ is not the main language. Our engineers don't know how to maintain C++ apps. So we essentially built an equivalent of TensorFlow serving, but inside using Java and Scala, and we ship that app to our customers. This is mainly for internal maintenance so that our teams knows how to be on call and fix issues for the serving solution, and also it's for tighter integration with our internal observability stack. This allows us to integrate with our monitoring and alerting solutions seamlessly, because TensorFlow serving doesn't have that integration. Does that make sense?
Yes. So Deepbird V2 is very focused on bringing TensorFlow to Twitter. Does that mean it's a highly opinionated system and a user that is interested in using PyTorch, for example, isn't supported with Deepbird?
That's currently the case. So remember, like what we started with, the goal was we were trying to defragment the machine learning practices at Twitter.
Mm-hmm.
What we noticed was in 2000, around 17, we had users of Lua Torch, and we had TensorFlow users, we had scikit-learn users, we had XGBoost users. So this fragmentation caused several issues. First of all, it causes difficulty sharing. Different teams can't share their machine learning models, their tooling and resources, and sometimes it prevents expertise sharing as well. Like if an engineer wants to move from one team to another, he has to learn a new set of expertise in order to be effective. So that's when we noticed the fragmentation is a problem. And then we also noticed work duplication, right? So Twitter is a very large scale company, and I can introduce our scale maybe separately, but essentially we have to invest in a lot of resource to build duplicate serving solutions. For example, let's say to serve a scikit-learn model versus serving a PyTorch model versus serving a TensorFlow model. If we end up building like three different set of serving solutions, which is what happened before, it wastes a lot of engineering resource. So that's why Deepbird is an opinionated, like you said, a prescribed opinionated way of doing machine learning based on top of TensorFlow that tries to get our machine learning practitioners to do things in a consistent way that allows different teams to share machine learning models, share their tools and resources, and even knowledge across teams.
You mentioned scikit-learn. Is Deepbird also an abstraction for traditional machine learning workloads in beyond the deep learning workloads?
So there's really not a clear line between deep learning and traditional machine learning. So yes, Deepbird can support traditional machine learning. TensorFlow supports, for example, traditional machine learning methods as well. One of the widest used traditional machine learning method is actually logistic regression. It's very widely used inside Twitter. And in fact, there's really not a clear line between logistic regression and deep learning, because we can actually think of logistic regression as a one-layer neural network with a single output. So
Sure, but
the
often folks find the overhead of deep learning frameworks relative to the tools that they might use for traditional ML to be pretty heavyweight.
Yes. So, for example, TensorFlow itself, the estimator API is the main API TensorFlow recommends for productionization in TensorFlow 1. And that API, we acknowledge that it's very clunky, and many of our users don't really like it. They think it's too heavyweight. That's exactly what we provide in our Deepbird abstraction. We're trying to hide the complexity whenever possible and prescribe good defaults. So I usually use a camera analogy. Think of TensorFlow as a very powerful like DSLR camera. Many users actually prefer like a mobile phone, one button point and shoot camera. So what we're trying to do is we're trying to wrap TensorFlow inside our layer of abstraction. We try to encapsulate all the knobs and buttons on the digital SLR camera, and we expose a single button point and shoot solution. So this is a double-edged sword, right? It's most users like it, especially the production ML engineers. They really like solutions where they type a single command, it trains a machine learning model for them. But some of the more advanced users and deep learning researchers actually don't necessarily like the point and shoot solution. It's just like how a professional photographer might feel like it's an insult if you give him a point and shoot camera, right? So I would say, to answer your question, we added this abstraction layer to hide complexity of deep learning frameworks, such that if you want to do logistic regression using our ML platform, it's very simple. And we aim for like simple solutions where you type a command, we can launch training and save models on HDFS, and you type another command, we launch hundreds of prediction servers serving the model saved on HDFS. But we do need to think about how to cater to the more powerful users as well.
To what degree does Deepbird replicate a lot of the work that has been done with Keras as a front end to TensorFlow? It seems like there are similar goals in terms of increasing usability, although Keras is certainly not a one-button type of solution.
Correct. So I would say there's definitely some overlap. Essentially, TensorFlow 1.0 made this basically in TensorFlow 1.0. There are these two ways of practicing ML: estimators and Keras. Estimator was more targeting production use, scaling to large data set, while Keras was targeting ease of use. So Deepbird is basically building on top of estimator and hoping to improve ease of use. Upcoming in TensorFlow 2.0, TensorFlow is consolidating estimator and Keras into a single Keras API. So users no longer need to choose between scalability and usability. We also envision that going forward, once TensorFlow 2.0 is released, Deepbird will also most likely adopt the Keras-based API.
So that is the training element. Does Deepbird also offer features focused on experiment management, tracking model parameters, hyperparameter tuning, kind of that whole space?
Yes, we do. Before our ML platform, most of our customers tracked these in spreadsheets, and we noticed that. So we built a repository where our deeper training jobs can automatically push the hyperparameters used and the experiment name and the resulting metrics like PRAUC, accuracy, etc., into this model repository. And then you can query the repository for the experiments you have run and examine their hyperparameters and metrics.
Mm-hmm. And do you support visualization with TensorBoard, or do you have your own solution or an alternate solution for visualization?
We mostly visualize using TensorBoard. So when you when you launch a Deepbird training job in our internal private cloud, we automatically start TensorBoard to watch the training process and render loss and other metrics. Also, this model repository we just talked about, once you query for experiment that finished, there's actually a button right in the UI that says Launch TensorBoard. if you click on that button, it launches TensorBoard on a instance in our internal private cloud, and it points the TensorBoard to that experiment that actually finished running and shows how the loss came down and how the resulting metrics look like.
Is the platform also opinionated in terms of whether users use a notebook experience or traditional code files or IDEs?
We're not opinionated on how the user develop code, but we do offer a notebook solution that's integrated with our internal clusters. We offer this thing called PyCX, where our users can type a single command and it launches a notebook instance, and it tunnels to the instance and gives back a URL that the user can use. It's a semi-hosted notebook solution. Basically, our users can type a single command and we launch a notebook server on our internal cloud, and the user can use the notebook, and it contains most of the dependencies our users would need. But we don't force our users to use notebooks for development. Yeah.
And are you doing anything to try to streamline the process of going from notebook to production, like some kind of automated code pulls or extracting code extraction from the notebooks, that kind of thing? I've seen that from time to time.
Yeah, not yet. This is definitely an area that's worth considering. I've seen in the industry that there's PaperMill that allows people to execute notebooks as a parameterized script, and there's also Git plugins that allows people to create very nice looking diffs of notebooks. Those are not yet explored by Cortex, but it's a upcoming area that we plan to look into.
Also, hyperparameter optimization. Did you mention anything in that regard? Are you doing that? Are you providing a solution to automate that?
Yes, definitely. So this touches on the machine learning workflow component that I briefly mentioned earlier.
The pipeline orchestration piece?
Yes, exactly. Okay. One thing we learned about machine learning is it's a very tedious process, and when we don't automate, our users don't necessarily do things in exhaustive or they don't, for example,
if you don't help them too much, they'll stay on their laptops and do it the way they used to.
Exactly. And hyperparameter search is one of them. We noticed that it often requires very repetitive and tedious repetitions of experiments. So our machine learning workflow solution allows our users to perform randomized search and grid search by launching a large array of experiments on our internal cloud and automatically recording hyperparameters and the results. And they can essentially just pick the best solution. We also have a solution based on Bayesian optimization, where we have a service called WetLab. This is from the company we acquired. We give it the set of hyperparameters that we just tested and the results, and the service tell us back what's the next set of hyperparameters to test. It automatically takes into account exploration and exploitation and recommends sets of hyperparameters to try next. And that's so far seems very effective, and our ML workflow solution has completely automated solution for using WetLab. Essentially, you just need to say, I want to do hyperparameter tuning, and configure the hyperparameter tuner to be WetLab instead of grid search or randomized search. And the automated solution would take care of the hyperparameter tuning for you.
I guess what's the kind of the fundamental currency in this system? Is it code that's checked into a Git repository? Some people focus at the code level. I see others are dealing with containers and checking in and checking out containers. What's the kind of the key core artifact for your system?
For our system, the core artifact, I would say, are TensorFlow graphs, or actually the code that's defining the TensorFlow graphs. The TensorFlow graphs essentially defines the machine learning model, and as part of it, we also define which features are used. And after that, we send this for training, and training spits out another artifact called saved bundles. It's a TensorFlow concept, and these saved bundles are stored on HDFS for serving. So I would say the core artifacts are both the TensorFlow graph and the trained models.
And presumably you're versioning all of these and tracking the versions transparently to the end user, or is the end user thinking about development workflow explicitly?
The end users do need to think about development workflow and how they version their code.
Okay.
Essentially, the TensorFlow graph is code, so it's versioned by Git, but the models our end users need to version them themselves.
And have you seen within your user base that you've got kind of ML engineers that are very comfortable with that kind of workflow, but data scientists that are less comfortable with that workflow and prefer for it to happen transparently?
So we have definitely seen that. One of the things we learned was that there's a wide varieties of machine learning practitioners, ranging from machine learning engineers all the way to deep learning researchers and data scientists. And their use cases differ from like production engineering versus like more like exploration and analysis. And they prefer quite different solutions. And what you mentioned is one, right? Data scientists, they tend to prefer, for example, notebook-centric exploration and development, and machine learning engineers prefer to write code and just Git and check into Git. Right now, we don't have a very opinionated solution, or we don't prescribe a development workflow across this different type of machine learning practitioners. We start with catering to production ML engineers. We're in the process of starting to look at how deep learning researchers and data scientists use our platform and how we can make their lives easier.
We had jumped over to talking about that workflow or pipeline orchestration layer.
Mm-hmm.
Is that based on something open source like Airflow, or is it proprietary orchestration tool?
It's based on top of Apache Airflow.
Are you doing both kind of online and offline workflows with that? Are you like doing offline scoring and or batch scoring using the workflow tool as well, or is it primarily for the experimentation and kind of model development loop?
It's primarily for offline training. For Twitter, the online part is actually real time, right? So we have prediction servers for that. Machine learning workflow is for training the models. I didn't fully understand what you mean by batch scoring. Like our predictions are like this. Like a user comes to twitter.com. For example, we need to present advertisement. We immediately need to respond. So this request hits our prediction servers and we generate scores in a real-time manner. That's not using machine learning workflows.
I think we thoroughly explored the first thing on your list of like 7 things, and we're 40 minutes in.
I see. Yep.
We may need to be continued this. I am very curious about the meta team that you mentioned, and maybe we can spend a few minutes talking about what you're doing there, because it is an issue. The issues around bias and accountability and fairness are ones that are, folks are starting to realize they need to pay more attention to. And I'm curious how you've staffed up a team, what the charter of that team is, what the team's practices are, and how they're tackling this issue.
Sure. So this started from a year ago. Our CEO, Jack, publicly tweeted that we're committing to increasing the collective health, openness, and civility of public conversations.
Mm-hmm.
And as part of that, we're using machine learning to make algorithmic decisions to curate the public conversations, right? So one thing we realize is we don't yet fully understand the impact of those algorithmic decisions. And for example, these algorithms decide what our users see, right? And what people see might actually change their behavior in response to the algorithmic recommendations. And as a result, their behavior shift. And their behavior creates training data, which feeds back to the algorithms, feeds back to the training data we use to train our machine learning models. And this creates feedback loops. And it's not yet super clear to us what exactly these feedback loops cause. And for example, there's right now there's research about how machine learning in social networks cause like polarization of opinions.
Mm-hmm.
So we started this team called Meta to study like the bias, for example, and fairness and accountability and explainability of our machine learning models. And we're staffing the team by partnering up with UC Berkeley professors. This is for two reasons. For one, this is an interdisciplinary effort. It involves not just engineering. There's also social science concerns. There's legal concerns. There's, there's a lot of like essentially human concerns other than engineering concerns. That's why we want diverse perspective, and we're partnering with UC Berkeley professors and researchers. The second thing they bring is because we're thinking about fairness and bias, right? The third party, which is UC Berkeley, which is not really a part of Twitter, they bring I think they bring
degree of
unbiased
objectivity.
opinions.
Yeah.
Exactly. That's why we staffed the team to be a partnership between Twitter engineers and UC Berkeley professors and researchers. We want to make sure that we're getting perspectives not just from engineers, because this is not just an engineering problem, it's also a social problem.
And when I think about a role like this, or a team or a charter like this, and what we want from them in today's environment, it strikes me that a big part of this by necessity is kind of research and exploration and building understanding of these issues and how they play out in a network like Twitter's. But you also want that to have engineering impact, and you want to create a place where data scientists that are working on a problem, or machine learning engineers that are working on a problem, can take advantage of, some degree of expertise in a very kind of practical, tangible, today kind of way. How do you manage that dichotomy with this team?
Yes. So this team is right now the main objective is to provide, for example, tooling and resource to increase explainability and transparency of our machine learning models. For now, we need to first understand what's going on, right? Before we actually propose what to change. So I think for now, there really isn't a dichotomy yet between engineering impact and research. Essentially, we're trying to measure for the first step, and we are providing tools for different teams to be able to measure.
Well, Yi, this has been a great conversation. There's still so much more for us to chat about, but I think this was a very, very interesting exploration of Deepbird and how you're approaching training, and I appreciate you taking the time to chat with us about it.
Happy to continue the conversation next time if we get a chance.
Yeah, absolutely. Thanks so much. All right, everyone, that's our show for today. For more information about today's guest, or to follow along with AI Platforms Volume 2, visit twimlai.com/AI Platforms 2. Make sure you visit twimlcon.com for more information or to register for TWiMLCon AI platforms. Thanks again to SIGOP for their sponsorship of this series. To check out what they're up to and take advantage of their exclusive offer for TWiML listeners, visit twimlai.com/SIGOPT. As always, thanks so much for listening, and catch you next time.